Hey everyone, welcome back to my channel. Today we are diving deep into optimizing search functionality in Angular using Reactive Forms and RxJS. We'll explore how to create an efficient and responsive search feature with debounce, distinctUntilChanged, and switchMap. Let me give you a short overview on the tech stack I'm using. We are using .NET 8 minimal APIs which are running locally on my machine. I'll give you an overview of those APIs in some other video. And additionally, I'll be taking an advantage of AdventureWorks 2019 database, specifically the product table from production schema. And front end is developed using Angular version 17. So let's get started, and I'll quickly move to Visual Studio Code. So I hope you are already familiar with creating an Angular application using the Angular CLI and generating component with the ngGenerate command. For this tutorial, I have created a component called Product Search. To enhance our UI, we'll use Angular Material. We'll be using an Angular Material autocomplete text box for this tutorial as we are building a search functionality. All the commands are provided in the description. Before diving into the code, let me walk you through the structure of our product search response, essentially how the API endpoint functions for searching a product. As you can see here, we have a query string parameter called search text that allow us to filter the product based on specific text. If we don't provide this query, the endpoint returns all the available products. So in this case, for instance, total products without a search query found to be 504. Whereas let's say if I put a search text as bike and send the query, then I see the total products found as 5. So this is how the response structure looks basically. It includes an object with the total products representing the number of products found and the array of products with the name found products. Now let's dive deep into product search component. It's a straightforward component with simple lifecycle hook called ng-on init. And we have defined search control, an instance of FormControl to handle our search field. We are subscribing to the valueChanges property of this control, but what exactly is the valueChanges? Let's break it down. So valueChanges is an observable that emits events whenever the value of the form control changes. This is crucial for reactive forms because it allows to react to the user input in real time. Every time the user types something in the text box, valueChanges emits the current value of the text box. Next, along with the valueChanges, we are using pipe. So what exactly pipe means and what does it do? So pipe method is nothing but it is used to combine multiple RxJS operators into single observable sequence. It allows us to transform, filter, and manipulate the stream of values emitted by valueChanges. In this case, we use pipe to apply series of operators that will optimize the search functionality. We then subscribe to the final observable. One of the key operators we use here is a switchMap. So what does switchMap do? Let me explain it how it works. So switchMap operator switches to new observable whenever a new value is emitted. It cancels the previous observable and subscribes to the new one. This is particularly useful for search functionality because it ensures that only the result of the latest query are considered. Finally, we assign the filter products from the network call to the filter products property, which is of type product data. So product data is just like the contract we saw earlier in the Postman. Remember? Now let's take a look at our HTML part of the product search component. As I mentioned earlier, we are using Angular Materials mat form field with Angular Material autocomplete. We are binding the options received in filter products from the network call to the autocomplete options. For better representation, I am appending the product name with the product number separated by hyphen. Additionally, we have a div on the top that displays the total count of products received after the search. This is linked to the total product counts property as we saw earlier in the Postman. Remember? Alright, let's dive into how our application works. When you type anything into search box, it sends a network call to our APIs to search for products based on that keyword. This seems good, but there is a catch. Imagine you are searching for bike. As you type B, BI, BIK, and finally bike, each keystroke triggers a network call. This means we are not just searching for bike, but also for every partial match along the way. Why this is a problem? Well, it leads to unnecessary network calls and bloats our data. For example, there might be over 400 products matching B and only 5 actual matching bike. This discrepancy increases the number of network calls and the size of data set that we need to process. Now consider the scenario with over 500 users simultaneously using this feature. The load on our backend APIs would be immense, handling all these requests. So with this approach, here are some disadvantages. So it creates a high number of API calls. It creates a multiple duplicate request which we even don't need, and we also get some outdated results. So by understanding these issues, we can work towards optimizing our search functionality to be more efficient and user friendly. Now let's explore how we can optimize our search functionality using the RxJS operator called debounceTime. First, let's understand what this operator does and how it benefits us. The debounceTime operator delays the emission of values from an observable by specific time period, in this case 500 milliseconds. It waits for this period after the last emitted value before passing it along. This is particularly useful for search functionalities because it prevents the application from making an API call for every single keystroke, thereby reducing unnecessary requests. How it works internally: when the value is emitted, debounceTime starts the timer. If another value is emitted before the timer complete, the timer resets. In this case, again back to 500 milliseconds. Only the last value emitted after the timer completes is passed along. That means after 500 milliseconds. By implementing debounceTime, we ensure that application makes only an API call after the user has stopped typing for 500 milliseconds. This significantly reduces the number of API calls, minimizes server load, and enhances the overall efficiency of our search functionality. Let's see this in action. When I type B in the text box and wait for 500 milliseconds, a call is sent to the server. However, if I type entire word bike, only one request is sent for bike. This means fewer unnecessary API calls and more efficient search process. Let's explore another aspect of our search functionality. When I type bike, then remove E and again put it back. In this case, I see there is one more call going to server for bike. This is redundant since the search term hasn't changed. To optimize this, we can use another RxJS operator called distinctUntilChanged. Now let's see distinctUntilChanged in action. So now what does distinctUntilChanged RxJS operator do? The distinctUntilChanged operator ensures that only distinct values are emitted. It compares the current value with the previous one and only emits the current value if it is different. This prevents duplicate search queries from triggering multiple API calls. This is how distinctUntilChanged works internally. It keeps track of last emitted value. When a value is emitted, it compares it with the last emitted value. If new value is different, it is emitted, otherwise it is ignored. By using distinctUntilChanged, we can further optimize our search functionality by avoiding redundant API calls for repeated search terms. Now let's see our final search functionality in action. When I type bike, only one call is sent to the server. This is very efficient because it reduces the number of API calls and directly lessens the server load. If I remove E from the bike and put it back, you'll notice that no additional call is made. This optimization prevents redundant calls, making our search functionality even more efficient. Overall, we have achieved a highly efficient product search that preserves server resources and enhances performance. Thank you so much for watching. If you enjoyed this video, please consider subscribing to my channel. Let me know in the comments if there are any other topics you would like to learn about, and I'll be sure to create a video on them. Also share this video with anyone who might benefit from solving real-time search problem. Thank you so much for your support and patience.